Here's the solution for day 2, problem 1. Identify the x-intercept and y-intercept for the graph of 4y equals 2x subtract 6. Here is a linear equation. It's not in the form where just the letter y is alone to the left side of the equals. It has a coefficient in front of the y. It also is not in the form where the x term comes first and then the y term and then the constants to the right of the equals. But none of that matters. We can find the x-intercept and the y-intercept in the same way that we always do. So let's start by finding the x-intercept. To do that, put a 0 for the letter y. So 4 times 0 equals 2x minus 6. 4 times 0 is 0, and that equals 2x minus 6. And now we want to solve this equation for x. We can keep working it out step by step or solve it by guess and check. For instance, how about 2 times 3, which is 6, and then take away 6 makes a 0. And so x has to equal 3. Or we could keep working it out step by step, right? So plus 6 plus 6. 0 plus 6 makes 6 equals, and then drop the 2x down. Okay? How about 2 times 3 equals 6? Okay? Or keep working it out step by step. Divide 2, divide 2. 6 divided by 2 is 3 equals x. Okay? So either working it all the way out line by line until you finally get an answer for x, or earlier trying to do a little bit of guess and check strategy in your mind to save writing. Regardless of how you do it, we'll get x equals 3. And so the x-intercept is 3, 0. Let's find the y-intercept. To find the y-intercept, put in a 0 for x. So we'll have 4y equals 2 times 0 minus 6. Let me separate this other work away from this so it doesn't get confusing here. 2 times 0 is just 0, so this makes 4y equals negative 6. Now divide both sides by 4, so y equals negative 6 divided by 4. And then we can reduce this fraction and also change it to a mixed number or a decimal. So that's going to be negative 1.5. And so our y-intercept is 0, negative 1.5. We're going to graph this dot on the x-axis and this dot on the y-axis to do question B. So 3, 0. Here's the origin. There's 3, 0, the x-intercept. Now 0, negative 1.5. Here's the origin. Down 1. And then halfway to the next grid line. There's negative 1.5. And draw a line through. Now day 2, problem 2. The height of a plant, h of x, is a function of the time it's been in the ground, x, in weeks. A plant was 4 inches tall when it was put in the ground, and it grows 2 inches per week. And so we have the initial value, 4 inches, and we have the rate of change. It grows 2 inches per week. We're also told symbols to use when writing our equation. So question A, let's write the function equation. H of x equals, this means the height of the plant after growing for x weeks, where x can vary, and it equals the initial height of 4 inches plus 2 inches per week. And here's how you show 2 inches per week. Question B, let's use that function equation to find the height of a plant at these points in time. So first of all, h of 3. What is the height of the plant after growing 3 weeks? 4 plus 2 times 3. 2 times 3 is 6. Add 4 is 10. 10 inches. Let's find h of 5. What is the height of a plant after 5 weeks of growing. 4 plus 2 times 5. That's 14 inches. And last, h of 12. What's the height of a plant 12 weeks after it's planted in the ground? 4 plus 2 times 12. 2 times 12 is 24. Add 4 is 28 inches. So the function equation shows us in symbols a relationship between height of a plant and the number of weeks that it's been in the ground. And then that function equation can be used to find heights based upon different numbers inputted for x.